This is term 2 and we're in lesson 4 and we're looking at absolute value. We're going to do quite a bit of work in slides for this assignment. I do have it scheduled for 2 or 3 days, so you'll see what I mean, but there's actually a creative project in here, and we have 2 Desmos activities and quite a bit of exploration. So you will need to determine how much time, but I would say 2 days for sure, maybe 3, depending on what you choose to do. So let's take a look at the first part of this activity, exploring the absolute value. The first thing we're going to do in slides is simply just fill out a table. You're basically gauging where your kids are with absolute value if they already remember what it is, what it means. A lot of kids will tell you, oh, it's positive, and that's kind of the reason we're doing this assignment, is just positive is not enough information. What do you mean positive? But they will give values in the table, fill out the right side, and I'm giving them the scientific instead of the graphing calculator just to show them something different. And then they're going to type what do they notice in the values. So they may notice symmetry, they may notice some of the numbers repeat, everything gets close to 0 and then gets further away again. So just solicit questions here. Then they're going to go to GeoGebra and look at a number line, and they're going to write in their own words what is absolute value of any number, and they're going to type, and they're going to insert a screenshot of one graph. Now this particular activity does have below it some questions, so they'll go ahead and do these questions, and then they will check their answer. They get up to 3 checks, so they should all get them correct. But they are going to use this value of A and move it. So as the A moves, notice the number on that little line there, that ray is changing to match the number here. So the absolute value of 7 is 7. The absolute value of -4 is 4, and so forth. So they're going to answer some questions related to this. This is just getting them in the mindset of a number line. And then after they've done this one, they've answered these questions, you do insert one screenshot of just one of the graphs here. They're going to answer this question, what is this situation, and how could absolute value help you answer this question? Like, which of these people, Joel or Emily, is further from sea level, and how can absolute value help? And then finally, this part is where I would say you're going to spend most of your time on day 1, is exploring this, and this is representing distance between 2 numbers on a number line using absolute value. But what's going to happen is they're going to go to the screen, and it does it pretty much for them, but their goal is to create this, x minus 1 equals 2. So when they get in here, it's not going to say that. So they're going to have to figure out, well, where should I put this? Oh, this needs to be at 1. And then this needs to be at 3 for this to be the same. So they're going to play with this until they get that expression. And then down here they're going to click this slider, and it's going to show them the statement, the distance between x and 1 is 2 units. And so they can see that this distance to the left and to the right of the center, which is at the 1, is 2 units. And so, yeah, and they can turn this back off, and it labels its center and how far. It kind of covers that up when they do. And then I do have them answering quite a bit. What is the center? Well, the center was 1, and the distance was 2, because it's 2 spaces away, and hopefully they see that here. You may ask them to just try to answer these first before going, and then they can get in there and play with it and see if they can get it to match, and then answer the rest of those. Where do you see the solutions? Well, the solutions are going to be they're going to be 2 spaces away from the center, so there's actually 2 solutions in this case. Then they're going to do it again, this time with a double negative. You might mention that, that might not be written that way. If I were to give you an equation later, I might put x plus 3, but you should know that's the same as x minus -3, so they're equivalent. But what would be the center this time? And you can actually see it. And what would be the distance? And you can see that as well. That's the distance between the 2 numbers. And then what 2 values of x will satisfy the equation. Hopefully, you might even have them guess before they go, and then use the tool to answer the question. And here's where you're really tested them. What is the center in this expression when we're just using a and b? and what is the distance. And I'll have all this detail in your teacher notes, but my goal is for them to create something here. So they're going to actually type over this question mark, and they're going to put in whatever values they need to put to make the x values come out to be -2 and 4. I give them some hints in their notes about how to find that center, since that's not provided for them. This right here, if they can do this one, when they're just given the answers and they can kind of work it backward, then you know they really know what they're doing. And the kids that are just trying to memorize the process and follow it, they're not going to know what they're doing. So this will kind of separate your kids in that way. And then you can go back over it and have the kids talk to each other. You can put them on the boards. You can talk to them yourself. But our goal is to get them to see that the number in here that's being subtracted from the solutions is this is your center, and your x is being subtracted from your center, or vice versa, because this could be written either way technically, since you're taking the absolute value. And the distance is the absolute value. So the absolute value represents the b. The absolute value of that difference is that distance. So they should be able to figure out the distance from the center to one of these numbers by simply figuring out the center by using these two numbers. So I'm going to let y'all play with that. Then this one is going to be a more general statement. I tell them this is to generalize in their notes. You're coming up with a rule that'll work for all cases. So what would the center be in this statement? And what is the distance in this statement? Let's put this a, this b, and this x in these blanks. Where would they go? Drag and drop them in there. All right, and then finally, they're doing this again, but they're creating this one. So they'll use the same GeoGebra thing, create it, and then finish this sentence. The distance between what and what is what, and what are the two values of x. So they're just doing it again. Same distance. You're going to do this. Now notice, it's time it has a plus sign. So we'll see if they remember. The double negative gives them the plus sign. All right, and that concludes our GeoGebra. And I think that is going to be all of the slides for day 1. So I did give you quite a bit of time to do that. And if time permits, on day 1, you would go ahead and do the absolutely amazing Desmos activity. Here is the Desmos classroom activity, and in this one we're going to explore what absolute value will do to a function, and it's actually quite interesting. This gives them an intuitive understanding of the whole point of their parent function for absolute value. So let's click on the first graph. This is the a line, y is equal to x. So the question is, what if I did y is equal to the absolute value of this function? So they would sketch their prediction. Now for this activity, for it to have any impact whatsoever, it's super important that you pace them, because every one of these gives them the answer right after. So I would pace all the class to here. You'll notice the calculator button is not present. So hopefully they're not all running out to get their Desmos calculator to try to do these, because the point is to predict what they think it will do. So some kids won't have any idea that what it's even asking them until they've done a couple, but maybe a few of them will be able to think about, well, you know, some of these negatives may disappear. I shouldn't have any negatives. You know, here's a -5. This point has a -5, -5. They may think it has to come over here, go up here. Maybe they know this part looks okay because everything's positive. I don't know what they're going to think, to be honest. So just see what they can do, and it'll be interesting. But then the next slide, you're going to paste to here. Here's the original line, y is equal to x. When they click here, it's going to create the absolute value. Now you may want to point out this is part of the graph right here, this blue, and it's in both the first and the second quadrants. Maybe talk about the quadrants in case the kids don't know the numbers, because they might want to use those to describe what they're seeing. So this is quadrant 1, 2, 3, 4. So they can talk about quadrant 1 really didn't change, but the part in quadrant 3 changed. It's now up here. All right, so the next part is this one. Another parent function. This time we're doing something that's in Algebra 2. So this works for all kinds of functions. They don't have to know the functions to do what we're doing. So they're going to sketch over here what they think this is going to look like. And then they're going to come to the next slide, and right here it's going to turn on the absolute value of that function and show them what it means. This one's really cool. They're going to do the same thing. And by now maybe they're getting an idea of what's happening. Hopefully more kids are going to have some clue as to what to sketch. And then here it is again, they're going to sketch to see what it does. So if they don't get it, they can always go back and fix it. So on each of those screens, pace up to the slide that you're on so that they can go back, but they should not be able to go forward at any time during this lesson. I would have them just going backward but never forward. And then on this one, we're saying what in the world is going on. So you probably will have some students that have an idea, and you will have some that don't, and that's okay. We just want to see what we can get out of the kids here. So solicit questions. I do have some teacher moves down here. What's happening in quadrants 3 and 4? What do you notice about the negative values for y? Why are there negative values for x, but there aren't any negative values for y in the absolute value? I mean, you could solicit this stuff, but you want to try to get it from the kids. I have given you some sample answers kids might come up with, and I'm sure they'll have other ways of wording some of these things. But this is where your conversation is happening. So encourage that. Now when they get here, we're going to do this in a different way. Instead of doing the absolute value of the function, what if we did the absolute value of the x and then graphed it? Like put that in the function and graphed it. So some of the kids won't get this, and by the way, this standard is technically an Algebra 2 pre-cal standard, so they don't have to get this. But it is interesting, and that's basically all we're doing here is exploring. They're not intended to learn this concept, but it's just giving them a way of understanding that what absolute value is doing. And it's really it's like a reflection. All of these create some sort of reflection in the graph. Notice this part remains the same, but this part's flipped over here. And then they're given another one. This is a logarithm function. Again, they don't need to know this function, but they can make a prediction as to what it would look like if it is transformed, but like this with an absolute value. And then they'll come over here and do it. And then this one does kind of a really unexpected thing. I'm not going to show you this one, but this is a trigonometry function. And what do you think it's going to happen to this one? And so there's that one. And then finally, they're going to summarize, well, what's going on this time? If we took the absolute value and then we put that in the function, then what happened to the function? And then finally, we've got a couple of examples. What's happening here? That's when we took the absolute value of the function. And then this one is where we took the absolute value of the x. And you'll note they're very different, not the same at all. That's important to pay attention to. So anyway, this is something you can use to just explore. It's mainly for fun. It's basically giving them a little bit of intuition so that for the kids that do go on in their mathematics, they're going to see a lot of these functions later on down the road, and they will see how absolute value impacts these functions. And that would be the end of day 1. Perhaps you would be into day 2 at this point. So on day 2, they will be given this graphic and they will make a guess, like how many gumballs do you think are in this container? And then they're going to go click on this table and they're going to add their guess to this. Okay, so they're going to add it to this table at the bottom. So they will just click at the bottom and they have to type a number in. There's a whole bunch. Now it says type fx1 in the header for column 2. So they're going to type f of x1. And then they're going to type zoom fit. Well, I'm not going to click zoom fit, but I'll show you where it is. It's down here. And when they click zoom fit, they should see their points. So that's all I'm going to say. I don't want to do it for you because I want them to do it without seeing this. But once you do that, it should be clear what's going on. There should be a pattern in the data. What does the x value represent? Well, that was your guess. It said put it in the x column, so that's your guess. And then what does the y represent? Well, it tells you right up here. X1 is your guess. Add your guess. And so the y1, it doesn't tell them, but it's actually represents how far off they are, like how far away from the actual answer. But I don't tell them that, so hopefully they can figure out that's what it's giving them. And if they can't, that's okay. At this point, you might have to tell them, but let's just see what they can do here. And then once this is done, all the kids will pretty much have the same graph. It's only got 1 point different, and it would be their one guess, so it's going to look pretty similar. So what we have here, they're going to create their own. So they're going to come up with their own quantity of something that is unique to them. It could be the length of their forearm. It could be the distance to their house in miles. It could be the number of vacations they've taken their whole life. It could literally be anything, but it needs to be a quantity that is unique to them. How many pets they've owned over the years. Some people have a ton of pets, and so that's a big number. Some have just a few. Yeah, lots of creative ideas here. If it were me, I would ask every kid in the class to come up with their own unique thing and put it on the board. And once it's on the board, no one else can take it. That's the way I would handle it, because I'd want them all to come up with something different and not copy someone else's idea. So if one child did the distance to my house in miles, somebody else would have to do something else. They couldn't use that particular quantity. But do it however you want. After they've come up with their quantity, they have to gather their data. So they need to ask people to guess what it is. And they can't tell them, so it needs to be a quantity not everybody knows already. So you wouldn't ask them like, what's my jersey number? You know, if they're on the football team, because most of the kids that have been to the football game are going to know their jersey number. Once they've asked their people to guess, they need a minimum of 20 people. They will create their table. They can do it in Desmos.com. And then the y value will be the distance from the correct answer. Like how far off were they? So if it's too high or too low, just put a whole number, hopefully. And then they're going to create a graph equation, and they do need to put text describing their quantity. Now, this is a perfect example of a portfolio artifact. So the kids could use this to put in their portfolio of something they created themselves. So what they're really doing is creating an absolute value function to represent a real life scenario. And then they can describe what are these, they could go in depth and really explain the graph and what the numbers in the graph are revealing. Maybe what the vertex of the graph is revealing. That would be an interesting thing to discuss. They have not learned the term vertex yet. I haven't introduced it. They may already know it from a prior class, but they probably won't know that here. We're going to be getting into parent functions in just a bit, and so that's when we're going to introduce some of that vocabulary, vertex, and so forth, and axis and things like that. All right, so that would conclude this part of the activity. Now, they do have one more Desmos activity, and they probably need to do it before they try to generate equations for these last two slides. And I even say that in their notes. Be sure to do your Desmos activity and come back and do your equations. So they can do the same here. Make sure they get the Desmos in first. So let's take a look at that. Okay, so this last activity is a Desmos activity, and it's dealing with the transformation of functions. So I won't give you the answers, but I did leave you lots of good notes and teacher moves, so be sure to check that and sample responses. So on this one, what do all of these graphs have in common? These are all absolute value functions. They may know that by now, but they might not. So you can ask them what they have in common. Then we're going to make a table of solutions. They've actually already made a table of solutions that have, I think, all of these same numbers, so they may think to go back and get those, and that's fine. Once they plot them, it's going to make this V shape in the graph. Then when they get over here, they're going to type this just like that in this blank, and it will graph that on this graph when they do it. And they need to describe what happened to this V shape when they typed that in. And then this one, they're going to complete a table for this. Observe the graph to the left. Now, I did put the graphing calculator in here, but if kids are using that, I would still ask them, could you do this without it? Do you know what you're doing here? These values of x go in place of this x, and then you work that out to get that number. So be sure they know what they're doing as much as how. I mean, to get the right answer is great, but we want to know them to know this equation is useful for them to get this answer. And then finally, once they do that, it is going to plot the points in this graph so they can see it. And this one, it will have those same points on here, and they're going to talk about what's the difference between this green graph, which was your original absolute value function, and then this new one that's going to be red and dotted. What happened? We call this a translation, and then they can just talk about what it did. I've got some teacher moves down there to read, so be sure to check that out. And then this one, they're moving the value of A up and down. The question is, how does that value of A affect this graph? Yeah, what's that number 6 going to do to it? How about 1? And so forth. This one is having them match a particular graph and choose the value of A. I won't do it for you, but it's pretty clear. I did put answers in the teacher notes, so be sure to check those. This one, they're evaluating, or they're choosing values for A, H, and K that will translate their graph. One thing I do point out in the teacher notes, and I would point out to the kids at some point, that minus sign means the x-coordinate of the point in the equation will normally not look like itself. Like this x-coordinate might be, let's see, -4, but you're actually going to use a +4 for the h because of the subtraction symbol that's actually in the form. So there's a little bit of confusion with that. I don't know when you should address it, but you definitely should address it at some point. It may not even be in this lesson. Maybe it's better to wait, but you'll see what I mean. That is going to be, they do that backward often. In fact, you'll probably see it soon. So the next one says, what do the A, H, and K do? So they're going to type in here text describing what each of those reveal in the graph of the function. And then finally, what are the values of A, H, and K that would make this graph? Like, what would I need to use for the A? And they can just type numbers in here and explain. A is this, and I would say this because at this one, though, it's a math box, so they can just type A equals H equals K equals. But when they submit, they can then go back and explain. So it's really a two-parter. When you get to 11, they do need to type this in. I wouldn't cut and paste because it does weird things. They need to type it in, and when they type it in, it should create the graph. And if it covers this up, they've got it right, and if it doesn't, they need to go back. They can go back and check their work on screen 10 as well. Your value for A, H, and K, did you do right? And then this one, they're going to type an equation that intersects the 3 blue points, so they need to go through all 3 of these. And then this one, they need to create a graph that goes right on top of that graph. This one is a card match. Again, if they can't see the graph, tell them to click on it. It will make it larger so that they can get a better look at it. But there's only 3, and they're pretty obvious, so hopefully this is an easy, quick card sort. The last activity they're doing is a marble slide. So they're going to create... if I click launch now, you see it only hits that 1 star, so they need to create a graph that will basically go through those stars so that it will let the marble hit all the points, all the stars. And that is the conclusion of this activity, and that is the conclusion for this lesson. This is a long lesson with lots of concepts in here. You may think, oh, they don't need all that. I can just skip this, skip that. I wouldn't do it because not only is some of this fun, I think the creative part's super fun, and the absolute value of those graphs is really, it's fun to see what your kids know when you do that. So I would encourage you not to skip that. But it's also kind of foundational. It's getting a better feel for what functions do. You're doing something. It's causing something to happen. Sort of like that function machine. So it's a good intuitive intuition builders, what I call it. Also, the number lines, even though it's not technically a high school standard, it is an important idea that they can use in future courses. If y'all have any questions about this assignment or need more suggestions about how to go about those creative projects with your kids, y'all let me know. Have a great day.